This unique film starts off with a high-level look at the complexity of the human brain and contrasts it with the capabilities of early computers. Two early computers are shown in the film, although they are not specifically named or described in detail. We have identified these as the British-made computer, the ELLIOTT 803 of the early 1960s, and the Soviet-made URAL-2 computer of 1959. The ELLIOTT 803 was a highly successful transistorized computer. A special feature of this machine was its use of 35mm movie film for its magnetic tapes. The film was manufactured by Kodak and formatted for the computer by Elliott Brothers Ltd. About 250 machines were built, of which only 3 survive. By contrast, the Soviet machine was a large vacuum tube computer utilizing ferrite core memory. It was built in 1959 for scientific use and deployed to various parts of the Soviet Union during the 1960s. About 139 of the Soviet machines were made. They were part of a larger family of URAL computers made during the Cold War era. We provide references for more information about each of these 2 machines in the appendix, following the Cybernetics film.
The most wonderful automat of the world is the human brain. It weighs about 1.5 kilograms and consists of many milliards of nerve cells and nerve fibers, many hundred kilometers long. No such complicated automatic device has ever been made by modern techniques. Dead elements cannot produce the electrical and chemical contacts that are within the body. No instrument can replace the experience and function of the human brain. No such machine can yet imitate the 1,000 different kinds of reflexes of sportsmen and the very fast movements made without previous thought. Victory within 1 second. The movements are so fast that they cannot be followed. Once again, slower. The attack starts. It ends in a trick. The sword is tossed upwards. From that, the opponent thinks there will be a blow on the head. His waist becomes defenseless. No, there is no mechanical automatic device so fast and so versatile. How much is 325 times 683? No, in such a short time, the human brain is unable to do it. But this way, the result is obtained in a second. If this is not fast enough, there is the electronic computer, which can add many thousands of figures in a second, or can evolve complicated mathematical formulas. These seemingly lifeless elements can also play chess. They can translate foreign languages or give a medical diagnosis. Can this same machine, in which only electric impulses move, be so versatile? Well, the different parts of the body, yes. The different organs of the body work similarly. Light and sound and different tastes and smells reach the brain through the various organs of sense. These impulses, which are the signs of the outer world, do not reach the brain in their original form. The nerve system is also constructed of uniform, seemingly motionless particles. Each nerve cell is joined to the next by complicated many-sided threads. If one cell is affected by an impulse, through a chemical process, an electric charge of a duration of a thousandth of a second develops, and then at once it loses its charge. This is repeated whilst the impulse lasts. The multitude of cells can affect each other by their actual connections. The impulse passes on with small delays to the neighboring cells, and with this, a series of electric impulses develops. In the nerve system of living beings, there are similar moving impulses. If a thin wire is placed under the nerve thread leading from the feeling particle of the peritoneum, the impulses can be illustrated. As the impulses are very weak, it is necessary to amplify them. The point of a needle has changed into such an impulse in the human nerve system. And what about technique? Well, the light signals are transformed into impulses with the aid of a photocell. While the sound signals are transformed through a microphone. With sound recording devices, every kind of stimuli can be perceived. This machine uses instruments which imitate the human system. Its eyes are photocells, and its ears are the microphone. First, it is able to move with the effect of light, and therefore it always automatically turns towards the light. Now it does not move, although it hears the sound. If the light and sound signals reach the insect simultaneously, the currents of the photocell and the microphone are connected in such a way that the machine shows logical behavior towards the outside. It is similar to a real conditional reflex. But the machine can be confused by unexpected circumstances. Two lamps, this is something new and unknown. Among the relatively few elementary particles, there is no possibility for the formation of so many connections to enable the realization of several logical decisions. Since each new condition influences the other, the more complicated tasks require several hundreds, or indeed several thousands of connections. If it was possible to look inside the human brain, it would be seen to contain many millions of uniform elements of the cortex, which are the nerve cells. Even when these appear to be completely inactive, they are still able to produce electric impulses. It is possible to even make a record of them. Whilst the centers of the cortex are not affected by any stimuli from the senses, the vibrations are unchanged. Something occurs in the brain with the effect of stimuli, which lasts as long as the stimuli last. The eye reports. The ear reports. Although the impulses are seemingly uniform, they affect different centers of the brain each time. This is how the human brain differentiates and knows the stimuli. Cybernetics tries to explore this process by constructing a model of the brain. The complicated multiple connections of the nerve cells are replaced by a number of electronic tubes and wires. The various elements which stand apart become centers, and each has a different task. For example, there is a mechanical mouse which looks for cheese. How would a real mouse behave? Now we see how the machine behaves. At each corner, the artificial mouse tries to turn left, to go forward. No success. This is already an experience worth remembering. Each time it touches the wall, a switch in the chest is turned to the forbidden position. Just watch it. Impending stimuli. Free-moving stimuli. Impending stimuli. The long complicated route is divided into small parts, into the stages of stimulus and impending stimuli. The human brain also gains experience through experiment. On the second occasion, it is the memory of the brain which guides the artificial mouse. After the switches have been turned to the correct and shortest route, it remembers it. The control board shows that whatever way the labyrinth is changed, the mouse recognizes and knows about it after only passing through it. Of course, it is possible to play on more than 25 squares, and each move can be dependent on several conditions. In fact, it is a chess game. On any of the 64 squares, 12 types of different players can be placed. The machines seen so far are too slow to count the many millions of variations arrived at in this way. The game of chess is made with electronic computers. Chess masters and mathematicians have summed up the general laws of chess in mathematical formulae. The strategic evaluation of the various moves and the changes in position must be expressed numerically. Since the chess machine only knows the language of impulses, the mathematical formulae have to be transformed. These are the rules of the chess game in the form of impulses. The memory unit of the machine is now learning. The first move is made by Mr. Laszlo Szabó, the international grandmaster of chess. He informs the machine of his moves by pressing a button. Although the machine expresses this on the board, nevertheless, it turns the moves into numbers. Now it is the turn of the machine. After a few seconds counting, the machine makes a move. After each move made by Laszlo Szabó, the grandmaster, the machine makes many hundreds of thousands of calculations, and among the possibilities it chooses that of the highest value. At present, the machine does not play better than man. But, for example, if man gives the machine some advantage, then the machine will recognize it. Mate. The machine is not only polite, but versatile. Since different letters and words can be turned into impulses, the machine also understands written texts. The machine is fed with a foreign language dictionary with grammar. The electronic machine will make the translations itself. A few lines are taken from a Russian language text. Instead of the text, there are impulses. In the activity of cybernetic machines and the human nerve system, there are similarities on which experiments on the organic connection of the living and lifeless organic matter can be carried out. After several months of preparation work, such experiments can be started. The electric impulses coming from the brain first go to the electronic computer. The computer, on the basis of a previously decided program, differentiates the nerve impulses, and from them it establishes the orders of the brain. Human thought guides the machine after a long and complicated process. In this way, cybernetics has opened a new age in technical history.